Hello.
Good afternoon, everybody. Can you hear me? Can you give me a thumbs up if I'm out there?
Yeah. Oh, there is huge amount of people here.
Hey, that's good. Right. Okay. Right. My name's Jason Fox. I'm the Senior Technical Manager of the FIWARE Foundation, and this session is going to be split into three parts. To begin with, I'm going to give you a basic overview of the LD bit of JSON LD and NGSI LD, but I won't go into the details of the NGSI LD API, which is what the context brokers use. At that point, I will pass over to my colleague Alberto Abella, who will describe the use of common data models within the system. And then finally, I'll get back to telling you how context brokers actually work. Now, for those of you who are familiar with context brokers, this will be revision background. You'll know what you're talking about. For those who are new to data spaces, need to understand what are the requirements which you might not have thought about within a system. This will actually be quite interesting, because the problem with data spaces, of course, is that you are dealing with other organizations. So let's get down to my presentation. We'll get the first bit running. Right, I have to get my thing up. I'm running. Right. So very, very briefly, if you want to leave after 5 minutes, if someone pinned me to the wall and asked me to describe what Fireware is in 3 minutes, well, start off with 1 minute. The 1 minute version is Fireware is an open source initiative defining a universal set of standards for context data management, which facilitate the development of smart solutions. Okay, so what does that mean in reality? Well, obviously, each of the words in that statement have been picked deliberately. The first thing you need to realize is that it's open source. So all of the software which is being provided for by the contributors to the Fireware catalog, it's free. You can download it. You can look at the source code. You can raise bug reports. You can fix bugs in the system. It's stuff which there's no initial fee to pay for. There are potentially certain restrictions on what how you can use things and how you could describe them, but that's your usual open source licenses. And it's what we're offering here is a universal interface. Universal because you are not restricted as to which domain you're talking about. Initially, I would say the majority of Fireware implementations were in the smart city domain, but we've branched out. We're in smart water, we're in smart energy, we're in manufacturing, we're in smart tourism. We've got a variety of projects across various different domains. You know your domain better than I do, and all of these could have some sort of feedback loop where you have a view of the world, an overall view of the world, and what happens is that you make a decision based on how that view of the world is working, and then you do an actuation, make a change to the state, and that causes a change to the state of the system. So it's a virtuous feedback loop. The simplest example I can give is, imagine you've got an agricultural system. You've got a soil humidity gauge in the ground, and the soil is dry. Okay, our system says, okay, the soil is dry. I need to make it wet. So it will turn on an actuator, it will turn on a water sprinkler, and then obviously that will cause the real world state of the real world to change, and the soil gets wet, and obviously it will switch off the sprinkler. Now that's a feedback loop, but you would get a better decision, a smarter decision, if you could obtain information from other sources. So imagine this situation with a water sprinkler, but as well as the data from the device itself, we are getting data from a weather forecast. And the weather forecast says it's going to start raining in 5 minutes. In that case, obviously, the decision software, which is your proprietary special source, would decide maybe it's not a good idea to put the water sprinkler on right now because we're going to get rained on anyway. It'll save water, it'll save money, and obviously it's something you can sell. So this is the idea of a smart solution. Smart solutions make better decisions when they've got more information. When their information is context data, what we mean by that is the state of the world right now. There is also a temporal interface to FIWARE, historical information as to where things were. But basically, the way I like to describe it is it's how are you feeling today, which obviously will depend on your domain. The sort of attributes you will require in a smart city solution will be completely different to those if you're dealing with manufacturing or you're dealing with logistics or whatever. This goes back to your domain, which again, this is what Alberto will be covering later. So going back to what is NGSI, what is FIWARE, those 5 bullet points are the summary of the next half hour, basically. It's actually the next 3 hours. The summary being that it is REST done right. REST being a mechanism of altering the state of a system. That's what the S is, based on your entities, your stuff. There's obviously a standard mapping of HTTP verbs and status codes. So if you want to retrieve information from your humidity device, it's going to be a GET. This is the idea behind this is we're not surprising our developers. If you want to change the status of your water sprinkler, it's going to be a patch, and so on and so forth. Now, the structure of the payloads is important because in the broader sense, what we're trying to do here is we are trying to allow systems to exchange data, and there has to be some ground rules as to where you put your brackets, how you put your payload in. So it's not just JSON, but we'll start with JSON and we'll move on to NGSI LD later, and then you add up with the additional information. Now, the final 2 points are complementary to each other. Registrations to augment context. This is where you say, not only do I know about devices, I know about weather forecasts. I know about the where my workers are in my system. That again, there was an example, working example in France, where they've got one of these things to maintain. I think they're rugby pitches, and one of the sources of context data they have there is whether the rugby field is in use or not, because regardless of whether the pitch is dry or the pitch is wet or not, you're not going to turn on the water sprinklers in the middle of a match. So whereas some people say, it's all IoT devices and what have you. No, it's not. It's broader than that. Context data is not just your IoT layer. It's anything which could help influence your decision as to what's going on. And the final point here is this publish subscribe mechanism. Now, obviously, some decisions are asynchronous. We want to be able to send information out to other components around the system. And as such, we need a mechanism to be able to subscribe to changes of data or retrieve information that something has happened. So again, the publish subscribe mechanism, this will be at the bottom of the hour, about 6 o'clock this evening. We'll be able to get the information coming through. This is a very common slide which you'll see in the introduction with multiple introductions to Fireware. There is a series of, I think it's about 35 components in the Fireware catalog, which can be found on GitHub, which describes all sort of useful things which you can get for free. You can provided you have a context broker, which is the central element in the core, the context broker can retrieve information from IoT devices, or I don't know, Excel file you put into a system or whatever, and it will hold the current state, at which point it will pass data up into the processing layer. Now, there are in the processing layer these sort of mauve color at the top, various elements which you might want to use. You might want to deal with real-time processing of events, windows of events, where you might want to put stuff onto a dashboard. These are all common stuff, and you can get that for free. If you want to write your own dashboard, if you want to write your own analytics software, you're free to do that as well. You own the thing which you are forced to have within any Fireware system is a context broker. For those of you who are looking at creating a data space, you should consider that each of your players in your system should have their own context broker. That way, I've got my data, you've got your data. I might be able to get a copy of your data. I might prefer to actually just say, can I get it directly from you? There's no point in me regularly polling and downloading your weather forecast if what I want is to make the decision based on the right now. So you can imagine the weather forecaster has their own context broker, the farmer has their own context broker, and the decision point, which is your processing element, will need to request information from both. Now, as you probably noticed, so far, I haven't mentioned security at all. There's a reason behind that. Security, Fireware itself is agnostic as to which security system you're using. We will be dealing with security on the session tomorrow. But if those of you who've been listening to the people from iShare this morning would realise that actually there's a complementary fit between the iShare components and the Fireware components, certainly when we're dealing with data spaces. Because if I am going to let you retrieve data from my context broker, I either need to know who you are, or alternatively, I need someone to vouch for you. And that's distributed trust. And as I said, distributed trust is the area which iShare comprehensively covers. But in general, what we have here is that there are a series of components on the security side which will work with Fireware. There's some which are direct within the Fireware catalog, like Keyrock and Wilma, who follow our rules as to when things get published. There are others which work perfectly well with Fireware, like, say, Keycloak or Keystone. They don't necessarily turn up to the Fireware Technical Steering Committee all the time, but they are proven components which are used to secure your system. And this is the column on the right-hand side where you've got the stuff in red there saying that you need to have authorization access control. You may want to publish your data. You may have a public data going out. You may want to make some sort of analysis based on a huge amount of data, and so on and so forth. You can look at this slide. The details here can be found, as I said, in the Fireware catalog as to justification of why you might want to use a component. You're free to use them. You're free not to use them. You're free to trial them, which is probably more important, because it may be the case that your architecture works, maybe the architecture works. The only thing which is a requirement for a powered by Fireware solution is that there must be a context broker, there must be context data. Moving on to NGSI. NGSI is this interface. There is an NGSI V2 interface, which is JSON based, and there's a newer specification called NGSI LD. Now, NGSI V2 gives you the structure of a JSON payload. So you get all that layer, which we had the layers here from the IoT to the context broker to the analysis. That all exists with NGSI V2. This has been in FIWARE for probably about 10 years. The NGSI bit comes from the OMA specification for telephonic devices. So this is an old concept. FIWARE itself has been going around for about 10 years in total. So you don't get vendor lock-in because you can obviously switch in new components which connect to your context broker, which then pass data up to the next layer. And this interoperability layer gives you a viewpoint on where's the real world. And we've already got this ability to do the different architectures. So given that NGSI V2, which is JSON-based, already exists, why do we need another API? Well, it's not exactly another API. I'll go into that detail there. Why do we need this extension? And this is where we very much come into the area of data spaces. My data is useful to me. Obviously, if I have a single context broker talking to my devices and I want to switch in and out, or I'm a city and I'm just connecting to all the various different sensors I've got around the city, or I'm connecting to the CRM system or complaints or whatever. If I'm in control of everything, that's fine because I can just decide which system goes into my my data. And which bits of which model is being used for the data system. The problem comes when I no longer have a monopoly on the data I want to be using. If I'm sharing data with other organizations, or if I'm retrieving data from other organizations, they may well have stored their information differently to me. I can't dictate what they are calling their attributes. If they have an attribute like name, is it a login name? Is it the username? Is it just a strange NAME code? We don't know from just those 4 letters as to what that actually is. What we want to be able to work out is that we need to have a common understanding of this problem. The 2 examples I've got here, you may not realize it, but obviously there are borders everywhere. If you're looking at the car parking, imagine I've got a city. I want to know whether there's free car parking spaces. However, there may be an administrative boundary between my city and the town next door, and they could have a car park which is usable by people coming to my central business district, but it's not under my control. I need to be able to retrieve their data. Now, obviously, if I have an application which is deciding whether to put, I don't know, pricing controls of people coming into the central business district, it could be of use to me to understand this information from somewhere else, somebody else's data, somebody else's control, and I need to get hold of the information. A more obvious system where there always is going to be a little bit of friction in the system is if you look at the area of smart tourism. There are obviously international borders. If you happen to be a port, like this is actually the town of Menton, which is between France and Italy, there's going to be information about, say, events across the border in Italy, which you may want to promote to tourists coming off the cruise ship. As well as there are going to be obviously events in the town on the French side of the border and other information. Now, you're not going to tell the Italians that they all have to speak French. They are going to have their own developers are developing their own system, and they'd be naming their attributes according to a system which works for them. And obviously, they have the flexibility to build their own system. And when you want to start combining this, you've got a problem. Now, this problem has got a relatively simple solution, and this is the LD bit of JSON LD. I'm sure you all know what JSON is, so I'm not going to give you a recap as to what JSON is. But JSON LD is a minor modification of the JSON format. All the NGSI V2 payloads are JSON based in one respect or another. However, LD looks like a lump of JSON. You look at the thing on the screen, you've got attributes like name, born, spouse. You've got a funny little @ character, which is used for control elements for the ID. But you've got an ID for what this entity is. It's John Lennon. But then you've got this other element called @context, which this is where it gets a little bit confusing, because we're talking about context data and @context and what have you. @context is the key to JSON LD, because at the moment, all those other attributes are the human readable bits. They're all in English. Okay, if it was in French, it might be non or ne or whatever, épouse. The short names are different, right? But there's this @context file, and this @context file is a mapping format for allowing data to move from these short names to longer names. Because the problem is that these short attribute names are insufficient to distinguish things. Simple illustrative example. This is a guy called Harpreet Singh, who's working with in blockchain and smart cities, and he was on my LinkedIn feed at one point. This is another guy called Harpreet Singh, who also works with blockchain and smart cities, and you can see they've got the same name. They look different, but they're dealing with different things. How can you work out whether you want to talk to this Harpreet or you want to talk to this Harpreet? Well, the answer isn't that you call them Harpreet, and you can't call them Harpreet Singh, and you can't call them Harpreet Singh, the blockchain expert. You have to give them some sort of unique identifier. And I'd call this guy Har, but if you were trying to uniquely identify him, he would be http:/long URL sing HP 1069, whatever. You can work out that there is a real Har, a unique identifier as to what this is. This moves on to the definition of the smart data models stuff. So we have an agreement as to what is a name, what is a humidity, what is a whatever attribute you've got within your data model, what is a building. We have a common understanding. What you call it below that is entirely your problem. I don't care, because we would have a mapping which would work from A to B. You see, what you can do for NGSI LD is that you would have this @context element, and the @context element is a mapping of say Harpreet to that URL, or person to a long URL, or whatever it is, and you can use your preferred short names in your payload data. If you were to remove that @context element at the top of this payload, you would have a payload which would work perfectly well, would be valid NGSI V2. If you were to use a context broker and you decided to that your content type was application JSON, and you placed the @context into a header file you can do that as well. So again, you can remove this from the payload body. But the fundamental point, whether it is in the body of the payload or the header of the payload, is that there must be this AtContext element, and it must have data in it. Now, going back to the point here, this here is JSON because it's relatively free form. It's got key value pairs. This element here is NGSI LD rather than JSON LD because every attribute we've got has got a type, either type property, type relationship, or one of the subtypes of those. And for properties, it's got a value. For relationships, it's got something called object. Now, even this is not actually a requirement. This is the full fat normalized format. This is the format that machines like to talking to each other like to define, because you notice in the AtContext element there are two parts. There's one element which I've said Fireware GitHub data models. This is my viewpoint of the world, which is saying, I have people, I have names, I have born, I have spouse. But there's also another context which is called the core context. And the core context says I have types, I have properties, I have values. Every element of the API within NGSI LD is well defined within the core context. The core context says you must have, defines what a type is. And a type becomes a full URL, so that there is absolutely no ambiguity as to what that data is. Now, once we get onto the API, you'll see there's multiple ways you can get the data coming out. But this is trying to show you the most verbose format that is available. This is something where, because machines are dumb, they need to have the information drummed into them as much as possible, explicitly saying there is a difference between an attribute which is pointing to another attribute, which is a relationship, compared to one where you have a value. Now, in this case, you've got certain elements where things are unlikely to change, static data like the born element, but you could change your name, you could change your spouse. So there are, again, context data here where things would be able to change. The difference between an NGSI V2 and an NGSI LD payload is, as you can see, trivial. It's very difficult to see any differences in this slide whatsoever. But what you I will go through them. You can look at them at the slide yourself. Point one: the endpoint is no longer just /v2 entities. It's now NGSI LD v1 entities. Similarly, depending on whether you place the AtContext element in the body or in the head, you may want to change your content type from application JSON, saying my payload is JSON, to application LD plus JSON, which is saying my payload is a special kind of JSON. Below that, NGSI V2 allowed you to, for the attributes, now attributes of things like category, address, location, name, etc. You were able to freeform what the names of them are. So you could say, it's a Boolean, it's a postal address, it's whatever. That is now limited to being property, geoproperty, subtypes of property, or relationship, because those elements are all defined in the core context. You can still get the same information in if you were to annotate your context file properly. I'll go into more details again later, but just saying that you can no longer say I am now a Boolean, I am now an array. No, you're now just a property. Beyond that, you can see that various types of data are acceptable. You can put in arrays of strings. You can put in some sort of JSON structure as a value. You can put in GeoJSON as a value. You can see that both cases have got a point location there. The other minor difference is the way that metadata is dealt with. Metadata used to be just a single element, and it's now more complex. It's now properties of properties, or relationships of properties. So you can see the structure of saying this address has been verified has changed from A to B. More specifically, the NGSI V2 data model consisted of entities which had attributes which had metadata, one level, okay, and that was well structured. Whereas the NGSI LD data model is much more fluid. So you can have entities, properties, relationships. However, an entity can have a property, and that property itself could have a property of a property, and that property could have a property of a property of a property, and so on and so forth. Typically, 2 levels is enough for any situation, but you could envisage a situation where, let's say, you wanted to download the state of a smart building. You may want to get everything in one graph, all in one go. That would be possible. This means that the structure is much more comprehensive and can cover a much wider element of scenarios. You can see that the value of the value is defined in the core context, the value of the property, the value of the IRI. The difference between a relationship and a property is that a relationship is always pointing to another entity, and every entity has got a URI, so it's got a unique name, so you can get the data from that situation as well. Giving a few examples of this, you by definition, as I said, you have structure. You must have an ID and a type. The ID must be a URI. If you read the NGSI LD specification, it talks about URIs and URNs. It talks about URIs. It actually means IRIs throughout. So if you have a situation where you want to put umlauts over a letter, that's fine. You want to do some sort of accents on it, whatever. But it needs to be a unique ID. Now, the way that you do URNs is, again, there is a necessary structure there saying, I'm a URN. I am coming from in this case, the NGSI LD world. I have a type of building, and I've got a unique set of characters, STORE001 at the end. So I can uniquely identify that particular entity. Furthermore, when you define the type of the entity, it effectively is giving you the scope as to what sort of attributes are likely to be in there. Once again, if we go into the full details of the AtContext file, there's you can look at the AtGraph element of this other AtContext file. We'll go again, more details later, which will be able to tell you, okay, a building is likely to have a floor attribute, or it's likely to have a location attribute, or whatever. Now, within any entity, it will, again, depending on your domain, talking about what you're talking about, you have a series of properties. Properties are, as I said, with context brokers, we're dealing about context data. It's usually information about the state of a thing in the real world. You can have conceptual types, like, I don't know, an invoice, which is connecting various elements together. You could have a property which is, say, a link to some sort of persistent storage, which is holding an image or something like that. But fundamentally, properties are the state of the system. Now, beyond that, obviously, if I have a field like address, that could have metadata. And the metadata is usually property of property. So a verified address is an address property which has got a property of property called verified, which has got a value true. Similarly, you have relationships. You can have relationships of relationships. You can have properties of relationships. So if you have a hierarchical system, you could say person A is managed by person B. And you could have a date stamp in there, like you could have person A has been managed by person B since 2021. And also you could have further elements. So you can see how we have a knowledge, overall, we have a knowledge graph here, which is telling us about the state of the system, or alternatively, allowing us to go and look elsewhere. Now, this is where you need to understand the difference between a context data-driven system and a database. You're almost certainly familiar with the idea of foreign key, primary key, or what have you. Now, this is kind of the equivalent, but doesn't work very well. And the reason why it's done like this is because I am not in control of all of my data. I'm getting data from multiple sources. I don't know if the next city's context broker is currently online. So I haven't got a copy in my local database of saying what the data is. When I make a request, I get a request saying, okay, and this building is near to that building. I then need to make a second request to get that building, the relationship, to find out the current state of that building. I can't just get everything with a complex SQL query. The flip side of this, the upside to this, of course, is that when you do get data, you will be getting the current state of the world to the best of our knowledge. Obviously, once again, you're talking about a federation of context brokers. If something's not online at the moment, you won't get any information from it. Fine. Our current understanding of what this system is X. So this is why you get each entity is one step. This actually does impact how you should structure your data, because if you want to make a decision on various bits of data, it may well be the case that you want to add in, say, metadata or copies of information, so that you've got the information based around a single entity. We move on to saying how can you read the data. As I've said before, this is a REST API, so it's a simple GET statement to do a read. Okay, but then you see it looks a little bit more complicated than that. There's this, as I said, this, when I want to get something, I can either get it in plain JSON format, or I can get it in JSON LD format. That's my accept header. Obviously, accept header tells me, do I want it in JSON or LD plus JSON? But I also need to supply, this is the mapping file I'm using for getting my short names out. Remember, fundamentally within the system, every single attribute you see on the right, like address or name or category, is actually a long IRI. And they are very, very difficult for humans to read. Really easy for machines, but very difficult for humans. So that link header, which has got, which looks complex, but it's actually typically a copy for every single request you're making, is just saying this is the my definition of the attributes of the world. You will notice that I do not need to include in my link header the definition of the core context. That is assumed by context brokers. Now, if you look at the payload here has just got the a copy of the JSON LD mapping. It would be better if it had the array of both of them, and you can actually point to one, and it will just be ignored otherwise. But you can, as I said, you can either do payload body or the other one. Now, looking at category, there is a very recent update to NGSI LD, which will allow vocabulary elements to be passed into the system, and that's an example of it. I want to get back the IRI. So, if we have a series of well-defined IRIs, like something for property, something for relationship, it means there is no ambiguity as to what an attribute really means. This is a snippet from the actual NGSI LD core context, and you can see that the location where something is so fundamental that it is one of the elements which has been defined in the core context. The value of something is so fundamental, it has been defined in this system. So you wouldn't find NGSI LD attributes being given the name Standort or place or occupation or whatever. You would define them as being location, and the location is always this NGSI LD / location. You could, if you really wanted to, use those short names, but you'd need to map to this well-known IRI, saying that what I really mean by this short name is that long name. So again, there's no ambiguity as to what can be done. This is what I was going on about at vocab. Actually, before I go into that, you can see here on object, again, this is relationship. Not only is there an ID for object defined, but it says it's got a type of ID. So it's actually telling the machine that what an object is going to be a URN, which is pointing to another entity. This is where the syntax of JSON LD comes in. Now, you don't need to worry about that in the first instance, because this is the core context, which is defining how the API is. What you need to worry about is, what are my attributes doing? So you've got things like unit code or location or whatever. Now, you can see here that I can define values as well if I really wanted to. So in this case, I've defined commercial, office, retail as being IRIs. So this can be used on the right-hand side. As I said, enum is currently in progress. Now, I haven't gone into all the basic background of JSON LD because I don't work for the JSON LD Foundation. However, there are a series of excellent videos which are available to give you another reminder as to why this is all necessary. In the top section, these are fundamentally explaining what JSON LD is and why it's so good. Of course, for those of you who are more developer-minded, go off and read the specifications. You can read them directly off their website. They have a nice little playground. You can play with the system. What I have here on screen is the equivalents for NGSI LD. We'll be going into more detail for these slides. I'll be showing this slide or something similar a bit later on. And then the final point here, you need to define your IRIs, you need to define your models. We need to talk about smart data models, which I will pass you over to my colleague Alberto.
Okay, so thank you very much.
Before we do,
Okay.
I'll just say, any questions you want to deal with me before where we go into Alberto's section?
Jason, there was a question on the chat. I've partially answered because I need some clarification, but I don't know if the person who is Ilias Aliferis is willing to comment something else.
Schema validation. Oh, that's yes. This is a very good question. Wow. That's really, really good. There is a difference between saying the value I hold here is a number between 7 and 73, and the attributes of my system is a humidity reading. Now, unfortunately, the English language is limited in the terms it is used, and I think it overuses and reuses schema far too much. Now, again, once Alberto gets, once I shut up and let Alberto get 5 words in, he'll be able to say something else. But fundamentally, from the JSON LD viewpoint and the JSON LD AtContext, it is not defining the limitations of what the value should be. It could be defining the difference between various nodes. So you could say, if I have an entity, if I have a relationship, then the expected endpoint of that relationship is going to be either a car, a bicycle, a car entity, a bicycle entity, or a caravan entity. That is possible. That's your at graph. However, it is not validating that data. That is done by something confusingly called schema.json. And I'll pass over to Alberto. We could talk for hours on that one. Really,
Yeah. Let me provide just a simple question, a simple answer to that question. So the answer is that, is the broker doing this? The quick answer is no. But in smart data models, we provide some tools for that. But I don't want to, let's say, to start explaining the end of my talk. Let me share the screen if I can. Jason,
Yep.
could you let me
stop sharing?
Please.
There we go.
Here we are. Let me put here, share. Yes, here we are. Okay.
So far, we've been talking about data exchange, really, rather than data validation or data input. It's well, we've got 5 days of this, so we'll cover more of it later on. But again, if there's more questions like that, we can certainly cover in more detail later on in various sessions.
Okay, I want to ask one thing to my colleagues because now I won't be seeing the comments on the chat if there is any question. So please let me know if there is anybody making any question from the chat. So thank you very much for joining here. So I'm going to get into one element that Jason has drafted, which is, okay, we are capable of storing and retrieving information from the system, but maybe it will be rather convenient for the people using the systems to be capable to share the models, the information, the structure of the information that we want to share between 2 systems or between 2 applications or between two different organizations. So, and this is what the smart data model is about defining, since semantically, what is the information that we are willing to share in the system. So these are the goals. So basically, we are going to explore what are the smart data models and what relation do they have with FIWARE. Okay. Possibly we'll introduce some specific data models for verticals that can be interested. Remember that this is especially dedicated, this session, to the people who is joining I4Trust project for the second call. So, and of course, the last question, the last point to be addressed during this session will be, how can you collaborate or how can you contribute to extend some of the data models? Because I'm also providing here one insight that this is a collaborative initiative, so the smart data models. So the first thing I want to share with you, so you have this link. Let me just copy and put into the chat. So you will have all the slides. One moment here. I'm putting into the chat. Okay, going back. And another thing is that it will be quite useful for you to fill this document, okay, and provide me with the GitHub users, especially for those of you who are willing to contribute to some smart data models or to start doing some of the exercises that we have by the end of the session. The idea of this session is just not only to explain the smart data models, but also to provide you some examples and some exercises that you can do after the session or in the last minutes of the session, and eventually you can contribute with actual data models to the initiative. So this is the agenda. I don't want to get into that. First thing, who is managing who is governing the smart data model. So there are 4 organizations currently. The IUDX is the Indian Urban Data Exchange, which is part of the Ministry of the Home Affairs of India. TM Forum, which is a worldwide telecommunications association. Okay, Open and Agile Smart Cities. Okay, which is an association of cities, smart cities across the world, and of course the FIWARE Foundation. Oh my God. Okay. And what do we have here? So what the main elements of the smart data models? First thing is a community. It's a community, so it does not belong to a specific organization. These 4 organizations are the board. What they are doing is just providing the resources and the guidance, but the data models are contributed by the users. The other point is that detailed data models, and this is not a simple statement, because detail means that we reach till the end. If you are working with standards across the world, some standards are quite detailed, but some others is telling you, oh, and this thing should be done this way, but this way is not explaining specifically how to do it. What is the outcome of this kind of approach? That you can implement the same standard two different ways, and therefore the interoperability won't be factual. Okay. The other thing that is worth mentioning is that this is not an effort of this 4 organization, but with other relevant organizations. In fact, currently there are 86, if I'm not wrong, other organizations that have contributed to these data models. We care about the coherence and the consistency between the data models. Okay, so we try to not reinvent the wheel. This is one of the first principles, and the other principle is that if we have an attribute, an example as Jason was mentioning, on name, and name is a string, it will be a string for all the data models. So to the maximum extent, with some exception that I'll explain later. We have created a method for agile standardization, and when we mean agile, we'll explain later. But we are, let's say, in another temporal dimension. So when creating a new standard or a new data model could take months or even years in some usual organizations, standardization bodies. For us, creating a new data model is a matter of days, more weeks. If we have the information, this is clearly agile. So we provide this in order to extend the usefulness for you, for the users of the I4Trust, to be capable of being interoperable. All of you are going in some consortia that you have to share data. If you are going to share data, you have to agree on the contents of the information that you are going to share. And the smart data models are there in order to help you on doing that and not reinventing the wheel and take advantage of the experience of other organizations, but coming from real case scenarios. And this is quite a differential factor. What we do here is based on experience, so in actual examples. It's not something that we design or somebody else designs, but based on something. And in fact, one of the mandatory requirements for being part of the smart data models is to have an actual example. And they have to provide the actual example in order to get accepted. We haven't mentioned, but as Jason had explained with the open source base of the FIWARE platform, we are also open licensing everything. Open licensing meaning that you will be able to use these data models for free. You can share these data models. You can modify these data models to customize to your needs. And of course, you can share that modifications with the only restriction to give credit to the authors. Okay, and currently we are based on Git, and we have GitHub as a front end, but GitHub is not kind of a requirement we are using, but tomorrow maybe we can migrate to other platforms because it could be more convenient. And this last point is quite important in relation to what Jason has explained. We are connected with linked data, but we are agnostic. So what we have is a service saying, oh, if name for me has a meaning, and I want this name will be the one defined by, imagine, schema.org, we are capable of mapping, on providing a context mapped according to the schema.org. But if you want to use another ontology like Zaref or Sargon or whatever, we have the service specifically for doing that. So we are not defining these canonical ARIs, but we are here just for helping you to use wherever you want. But so if you want to use linked data, we are very glad that you do it, but we are not providing you with the canonical ARIs. Having said that, we create automatically some linked data in the case that you don't have or you don't want to use any ontology, any vocabulary, external vocabulary. Okay, and the other thing is, the other point mentioned here is that has to be widely adopted. So if there is a standard, has to be open, of course, and adopted. So it doesn't, it really restricts the contribution to those people who create the standards, but for any reason, the market is not adopting it. So I have to make you aware, why are you doing these things and what are the main difference? And let me point out how the digital markets are working for most of the standardization and why is that important? What's the difference for the smart data models? If you have a research project or an emerging market, it will take usually some years for the standardization bodies to detect this, and even another years for delivering into the market. What happens? That in a digital market, when let's say, the projects could last 2 or 3 months, or maybe long projects last 24 months, having years for creating a standard makes these standards irrelevant. Why? Because in 24 months, maybe a new market has been developed. And if this market has been developed, every agent in this market has created their own standardization. It's not a standardization because possibly they are not documenting, they are not creating any consensus, but they are doing something. And what is happening with that is that every agent or every stakeholder in the market is doing something which is not compatible with others. Okay, so then we came here with agile standardization. And what we do, what we can do is that either from a research project or for an emerging market, if they submit the information, we can create in a matter of weeks or even less in days, we can create something that we can deliver to the market also in days. And this is not, let's say, an alternative to classic standardization bodies, but something which is complementary, something that could be at market speed. Okay, of course, we are not creating everything that the standardization body is creating, like a lengthy description, a written description, but we create, let's say, the minimum elements of a standardization, which is what data elements do we have, what attributes will be included, what are the data types expected for these attributes, and a text description of the meaning of these attributes. And also a long ARI in case of you have the need for use the linked data. So basically, summarizing, what are the main differential advantages? So we change from months, years to something which is last days. Another thing is quite differential. So it's very easy to contribute because there is one single file. This file is the single source of truth, which is in our case is a JSON schema. In this JSON schema, if you are familiar with this format, you can define the attributes of any payload that can be defined. And JSON schema is much more powerful than a simple column names like a CSV file or an Excel file. Okay. But you have also there some other additional information like the textual descriptions or the models that reference this attribute, or eventually the recommended units and some others. Okay, all this in one single file, and out of this single file, everything is created. So automatically, which makes easy for us, like having, like in the fourth point of this slide, 7 languages. Currently, if I'm not wrong, the languages are English, French, German, Spanish, Italian, Japanese, and Chinese. And possibly some others will be coming because the publication process takes only 3 minutes. The other thing which is differential is that we are based on actual experience. This is something mandatory. If you are willing to create a new data model or to contribute, the first thing that you need is not only the description of the data model, but also the actual example. And based on our experience, we have discovered that examples rules against the schemas, because the schemas are defined usually how we think that they should be done, but the examples are how actually the things has to be done. And one of the tests that we do is that the schema that it's provided is validating the example, like your former colleague was mentioning. And if usually when there is any kind of a misalignment, the example rules. And the other thing is that the one data model could apply for several domains. When I mean domain is for different industrial sectors. Industrial sector like logistics, smart cities, or energy, or water, or many others. There are currently 13 of them into the smart data models. And we can change, in example, the weather. The weather is something which applies not only for what is the environmental, but also for energy, for the managing of smart cities, and so on. But we have only one model for weather. And this, whenever there is updated into the source, is updated for all these domains. Because one thing that we have discovered is that, on the contrary to some years ago, now most of the projects are, let's say, multi-domain. So if we are doing an energy project, this energy project is being affected environmentally, is affecting possibly the water resources, is possibly affecting some other things. So some principles about the smart data models. The first principle looks to be simple, but it's not that simple. Don't reinvent the wheel. So we have to take advantage of the experience of other users. Fortunately, we don't have resources for creating any data model. And therefore, we are not even trying to reinvent the wheel, because it's something that we, as humans, we tend to create, and we have this, I don't want to, stupid pride to say, oh no, I'm going to do this much better than others. To be honest, the experience is a quite valuable resource, and I guess that is what we are taking as profit from. So we don't create definitions. We have already more than 19,000 attributes defined. So possibly what you need is already in some of the data models. I've already mentioned that we are translating all the specifications in 7 languages. Okay. Every data model has examples. Okay. Whenever possible, we are following open and adopted standards. Okay, you see, and of course, the data model is not imposing you any restrictions on what you have to use. So, if you have a data model with, imagine, 30 attributes, like the ones that Jason showed you in the previous slides, you can use these 30, or maybe only 2 of them, because it is what is convenient for your use case. And of course, nobody prevents you to include additional attributes that is quite convenient for your use case, and you can include it. The broker is not going to validate this kind of additional attributes. Okay, you can validate if you wish with the schemas at the smart data models, but this is not something that the context broker is doing, because it's not his role. Its role, like the same way, is not the role of security. So we are agnostic to that. Okay. And one thing that was to be mentioned for those who are participating in the I4 Trust, you have to define the classes, or what is the data models of the information that you are going to share. So, and you can contribute eventually this to the smart data models. Another thing, when I was telling you that we are not reinventing the wheel, is because this is absolutely true. So, and you can see there some of the standards which are being already mapped into the smart data models. Some of them could be familiar to you. Some CPSV is for the description of vocabularies of public services, the European Union. GBFS is for mobility with bicycles and scooters. quite similar in the name to GTFS, but it has no relation. It's for urban mobility, or EPANET is for mapping large distribution networks of water, or frictionless data, or PCOA, Oslo, or HL7, which is the last standard which is being mapped. So this will be growing as long as the smart data model is running. Okay. What are the conditions? What are the restrictions for one of these standards to be adopted? Is that first thing, we need to be free to use. Okay, no cost. And this restricts, in example, the adoption of some of ISO standards. Why is that? Because the ISO standards are not free. Okay, and of course, we need something with a license that allows the modification and the sharing of the modification. So, or could be an ontology, but this ontology has to be adopted by the market. And you cannot imagine how many ontologies are around there, but not adopted by anybody. Okay, and what makes the difference? So if you can provide examples of people actually using this ontology, we're very happy, because an ontology is a very well structured document, so it's very easy for us to map it. But the restrictions of the examples applies to everybody. And one thing that we provide as an added value is that sometimes these regulations are not completed, so they left some parts undefined. And what we do is just to define this last mile of the standards in order to be usable, or complete usable and complete interoperable for the users of the smart data models. Okay, I've already drafted what is a smart data model, but basically there are three elements here. So first element is a technical description of the data types and the relationships of the attributes. And let me just jump directly, because this is better to be seen than to be told. One moment. Here, this is the main page of smart data models. Okay, you can visit. Okay, I'm going to put this into the chat for a moment. Oh. Okay, and let's visit one data model, this for flight. Okay, we're going to see the description. You see here a file called schema.json. This is the single source of truth. And maybe I'm going to enlarge a bit to make it easier. And you can see here some descriptions of this attribute: flight number, what is this data model. As Jason has mentioned, there is always a type, and in this case, the type is flight. Okay, this is the state of the flight, date EOBT, I have estimated off block time, so on, so on, so on, so on. Okay, many attributes defining a flight. Okay, and I've also mentioned here that there are some documented specification. Let me show you this documented specification. We go here. We are in, this is GitHub. Let me point out. Okay, there is a oh, sorry, yeah, we are in flight. We have these 7 files which correspond to the different translations of the specification. If we go to the original, so a description of a generic flight, and you see here all the attributes belonging to this data model. Okay, address, alternative, blah, blah, blah. If you are an expert on flights, possibly you are quite familiar. For me, it's kind of speaking in Chinese or Korean, a language that I'm not capable of dealing with. What else is here is also telling you if this is the data type that it's included here. When there are several potential types, there is an asterisk. Okay, this is already explained here below. Okay, and what else is here? This is the technical description. It's an equivalent of this JSON schema, which is here into YAML format, just for those technical guys. This YAML file can be also accessed independently. So if we go to the former location, you see a file here called model.yaml, which is the one which is embedded into the specification. Let me go back. What you see here also below this description, there are several examples. Okay, if we expand this, we can see just an actual payload, okay, of an example with all these attributes. And there are 4 of them, okay? So in different formats for NGSI LD, for NGSI V2, in key values, or in normalized format, okay? And all this is available for different languages, okay? This is Spanish, okay? You see basically the same information, okay? And all this is generated automatically because otherwise it could be impossible to be maintained. So we have seen 2 of the elements, the technical specification and the examples. The examples were also embedded, but we have here the examples in which we not only have those JSON example, but we have also in CSV format. Let me show you. So here we have the names of the attributes and a value extracted from the same examples. Okay, if you are willing to use this with a platform which is not NGSI LD, something that we don't recommend, but or maybe you are ingesting from a legacy system with this format, maybe this kind of format will help you. Okay, so let me back to the slides. Okay, so we see that these 3 technical elements. Let me insist, based on a real case scenario. Okay, so no, it's not a theory, it's not an academic research. And what is not a smart data model? So it's not an ontology. We are not describing the structure of the information. We are defining only the entities that are present into these data models. We are not creating a standard, so we don't create new standards. Okay, we are providing the data models. Of course, these data models could be the basis of a new standard, of course, but we are not the authors. And it's not an academic exercise. So some universities has approached it and tell us, oh, why don't you adopt this into the smart data models? And the answer is always the same. So do you have an actual example of somebody using this? And if the answer is no, I don't have anybody. So the answer is come when you have an example. Okay, this is the structure. So this is the way that you can find the information. There is an umbrella, umbrella repository called data models. And then we have in a directory, we have the 13 domains. Not all of them are depicted here. And in every domain, there are sub-repositories called subjects that can be depending on one of these domains or several. What is in the umbrella repository? There are guidelines for coding new data models. There are some templates. There is a directory with some scripting tools, these tools that make automatic the management of the initiative. Okay, and there is the official list of domains and data models. Okay, the raw version, because in the main site in Smart Data Models there are some services that, based on these raw versions, are providing you with a more suitable format for the information. Of course, you have these domains, which are. Let's see in reality how is this. Let me go here to the front. This data, this is, let's say, the main repository. We have the umbrella repository, which is data models, in which you have just information for the context. Some of the services we'll explain later. And then we have the specification. The specification, you can see here the different domains. An example, smart cities. Okay, let me go to the last commit. And we see the different groups: building, Oslo, which is an ontology, parking, parks and gardens, points of interest, and many others. Okay, if we go, for example, to weather, okay, we see that there are 4 data models here. See conditions, weather alert, weather forecast, and so on. Okay, so, and this structure, this is one repository called weather, okay, and there are 4 data models here. And there are another 2 repositories. One of them is especially important, which is called incubated. Let me go here, look for it. So incubated. What is this repository for? This repository is for helping you to create or to document the data models that you potentially are willing to contribute to the initiative. So you can see that there are many directories. There are around 200 data models being created right now. Okay, this is the queue. Okay, and this is I'm funny thing. I'm funny say that this is like the Wild West. So there are many things. Some of them are very active. Some others are quite close to be abandoned. And when we determine that they are abandoned, they are removed from here. Okay. I like to see here. You see the person. This is a data model which is very close to be accepted, and we expect you to work on that and to get it into the official data models list as a consequence of this training. Let me go back here. Okay, it's evident, but there are two main sites. One is smartdatamodels.org, we are going to visit right now, and the other is the repository that we have already browsed, github.com/smart-data-models. Okay, there are around 75 repositories. Possibly there is some new. Okay, and this is quite oriented to developers. But to be honest, it's much easier to find the information which is present at GitHub thanks to the smartdatamodels.org site. And let me have a visit to it. Okay. What do we have here into the main site? This site is thought for those people who are willing to use or willing to contribute the smart data models, but they are not an experts at the creation of data models. Okay, possibly you are very expert, imagine at agri-food or water, but I don't think that for contributing to a smart data model, you need to be an expert at creating data models. The first thing that you have is the last news. Okay, this is the mapping of a new ontology. It was yesterday exactly. We are creating a Python package, which is quite convenient for those of you willing to document the data models that they are using. Okay, because there are some functions that allows you to check if an attribute exists in the smart data models, and if it exists, it can provide you to the written description. Many other, there is 11 functions, and there is also a function for get the repository always updated. Or this is new data models published, or this is for water quality prediction, and so on. So every time that there is something remarkable, it will appear here. Now we have on the left extensive set of tools. Okay, the first tool that we are going to browse is the list of data models. If we are willing to know, oh, there is a data model about something, okay, imagine that, oh, is there something related with a vehicle? So we can write this, the starting, and then all the data models related with vehicle. Let me go to some, vehicle, okay. We can open it and you go directly here. If you have to do the same going directly to the GitHub, what will happen? You have to go to the main repository, go to the smart cities domain, then from the smart cities domain, you have to go to data model transportation and then to find out the vehicle. So what is better? Depends. If you're a fan of GitHub, of course, this is very convenient for you. If you are, let's say, a regular human, then it will be much easier to look for the word and to find out. Okay. This service also provides you with information about what is the subject in which this data model is located. So, in example, this vehicle is in the data model transportation subject. And you see here all the data models that are present here into the transportation subject. Okay. And additionally, there are some tags for qualifying these data models. An example, we have participated in a sure, not here, remove, okay. Oh, yes, sorry, I was writing down. This is an and. If you put several attributes here, it's an and. So these are data models coming from a single project, okay, and all of them are available here. So, okay, But what else is here? Possibly the next thing, I don't know if you are familiar with JSON schema, but I will take for granted that this is not the case. If this is not the case, and in order to contribute to the smart data models, you need to create a JSON schema, which is a kind of a JSON, not very complicated, but they have some tricks. So we have here just a service, which is an external service. We do not provide it. We can take this text and open in this new web, paste it here, and here on the right appears a JSON schema, a perfectly valid JSON schema. And the only thing that you need to know, imagine that I want to customize this field X, which is something which is a percentage between 0 and 1. So instead of field X, I want to call it my attribute. Then as you can see, it appears here. It appears here directly. Okay, and we have here in this text one example of every type: a string, a datetime, a relationship, an enumeration of strings, an enumeration of numbers, and so on. Okay, so with this you can draft you can really draft a schema without knowing much about how this service is created. Okay. Let me go back here. There are some other data models, so other services, sorry, for the generation of examples. Let me show you. So, or even better, in any of the data models, CityWork, okay. So we have here, we can generate examples. Because sometimes it's not working. Yes, it's not working because there are some limitations, and this is a very complicated. It's a very complicated schema. Let me go to something which is quite simpler. I guess possibly bike-lane. So here we are. Okay. So you can have, and whenever you update, you have a new payload with new values, which are valid from the point of view of the data type, but the information there is, of course, is random and is not useful for this point of view. What other things do we have here? We have also, yes, the generator from a JSON example. So imagine that you have a payload already in JSON, but in key values. So you can use this service. Yes, if you copy this, you paste here, you put here your email, and then it's drafting the JSON schema here. Is drafting with these attributes that you have created. Let me enlarge. Okay, it generates the ID and type, and because ID and type are special attributes, it's already providing you with a description. In this case, we describe an entity called test. So we explain that it has to be test. And we provide also an attribute called humidity. And this humidity has been detected that is present in some other data models. This was the case, is providing you with all the description. Okay, so possibly this description is already good for you, or maybe not. You could eventually change. And there is another attribute called other attribute, and therefore the system is not capable of finding another in these 19,000 attributes. If there is another, makes sense because other attribute is quite unusual. So no description is attached, but it's telling you, oh, you need to put a description here. Okay, what other, let me make it smaller, okay. And these two services are somehow advanced services, but quite valuable. This is the one that we want to explain for mapping the context of a data model, this context that allow us to use with unique IRIs, okay, and can allow us to map with different ontologies. Okay, let me show. Yeah, this is the configuration file. Okay, this configuration file, let me show you, is telling to the service, oh, please map all the elements of this data model according to ETSI ontology. What ETSI ontology? The 1.4, okay, which is described here. If these elements are not found in this ontology, then try it with schema.org. What version of schema.org? 1.0. Then if is not found at DETSI, neither in schema.org, then go for IUDX, okay? And if none of this is working, then go for Saref. And if not, it's left with the original. Let me show you with an example, okay? In this example, you see that some of the elements are mapped with the schema, schema.org, 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 but this annotation is not found in any of these ontologies, and therefore is kept with the Smart Data Models IRI. But some others are mapped with w3.org, which are coming from ETSI, and these ones are coming from ETSI as well, okay? So they are mapped according to the ontologies that you have defined. So if you're willing to use other ontology, it will be quite easy. You only have to get in contact with us, and we can create the mapping service for you. Okay. In fact, if you see the main site, the last post is the mapping of a new ontology. Yeah, here. Sargon is an ontology for energy, and now it's available. We make it available yesterday. Okay. And the last service here is the context merger. What happens when you have data models, we have mentioned, coming from different domains? An example, you have an example coming from buildings, coming from devices, together with the weather and so on. Okay, so you have to create a unique context. This service is helping you out for generating this merge context. You put one configuration file. This configuration file is merging everything that we have. So I don't think it's convenient for you, but instead of that, you can take 2 or 3 of this, which is the usual way of working, okay? And you can create, this is an example as well. So it's merging, if I'm not wrong, battery, device, building, and weather, okay, from an actual project. And some of them, you see that there is all these attributes, battery, coming from battery, another coming from building, another from device, and so on, from weather. And it also detects, oh, there are conflicts because battery level is used in device or in battery. So you have to choose. So it's not solving this. This is something that you have to fix manually, okay? And it depends on your use case. But what is providing this service is, oh, we are detecting. So this kind of conflicts is not going to be produced if you are using this service. So you can fix it. Okay, and these are the main tools if you are a contributor to the data models. There are several others, like this checklist for making easier to remember, or maybe you can access to the templates for submitting a new data model. So instead of using this editor, you have here just a draft of a schema. This is an actual schema, but maybe you can start from this kind of thing, which could be simpler. So it's up to you what to use. We are here, let's say, for helping you out on contributing. The easier the better. Okay. What is the current status? So we have data models in 13 domains. Manufacturing and logistics are rather new, so we have a few data models coming. But there are many data models in energy, in censoring. Censoring is rather special because there are sensors coming from many sectors. So if you see here this asterisk explaining, so there are sensors for smart cities, for health, for environment, for energy, for water, so on. Okay, for specifically for smart cities, for cross-sector is a domain that we use for those elements which are very useful or not specific of an industrial domain like weather. Yeah, is of course is very useful for environment, but it is also for smart cities. It's also for agri-food, for aeronautics, and so on. Okay. What else? What is the current status? We have 826 official data models, but there is 231 on the queue. So we exceed 1,000 data models right now. There are in the incubator repository that I've showed to you. Okay. This AAS, which is Asset Administration Solve for verified credentials, the GS1 mapping, which is for logistics, FineJust for agri-food, for CCVC is for cameras, and so on. Okay, and these are the last subjects, which are groups of data models, like SDMX, which is for the mapping of statistical information, HL7, which is related with health, consumption, in this case it's related with energy, marine transport for logistics, also for sustainable mobility, and so on. And this is just some information regarding the community. There is 86 organizations contributing, 131 persons, and we document the adopters. Oh, I haven't shown you this into an actual use case. We'll be sitting right now. Okay, what is an adopter? Let me show you. We are here. We can go to the same data model, flight. Okay. What is an adopter? An adopter is an entity using this data model. In this case, is the Aberdeen Airport. Okay, this is the description. In this case, they are not providing a contact mail, and this is the organization, and this is the project. And when is this data model starting to be used? January 2021. Okay. And there is another file that is worth to be mentioned, that everybody contributing to these data models, it can appear here into the contributors.yaml. This contributors.yaml, you can include name, surname, mail, organization, project eventually, okay, and the year, okay. All these attributes are optional, so you can include your mail or you can't, okay. The same for the project, the same for comments, and so on. Okay, this is the status of the community. Okay, and now let me just review a bit the main elements of the smart data model. First, the schema. This is the single source of truth. It's a JSON schema, includes the descriptions. It can validate the payloads, okay? It's always called schema.json, and it's present at the root, okay? It's never stored in a context broker. I've mentioned this because some of the users are taking this. Yes, it's a valid JSON, but it's not. It does not make any sense to store it into the context broker, and defines the attributes, the names, and the contribution to this. This is manually. The examples, of course, they are manual as well. Or to be precise, there has to be contributed as well. Okay, could be in key values and in normalized format. Okay. You know that key values is only an export format. Now we are implementing a new format called concise in the new versions of the NGSI LD specification. It's not present for the moment, but it will be in the coming future. Okay, the specification that we have reviewed is the format is a markdown. Okay, is generated automatically, so it's never edited. It's created automatically for some scripts, and it's the explanation of the data model. The subject is this directory, the repository containing several data models. They are located in GitHub. Okay, there is one folder for each data model, and includes, of course, this contributors.yaml file. Okay, and it has also a README listing every data model present, and this README also is created automatically. Okay, this is the AtContext. Oh, I haven't mentioned. Let me show you. Let me show you what is the AtContext. Let's go to any of these data models. Okay, aeronautics. There is always a file called context.jsonld in which every term called IATA is mapped with a long IRI. Okay, this long IRI we create automatically. It is not our goal to define these IRIs because we are not willing to create ontologies, but if you are using a linked data system, you need this. Imagine that there is no ontology mapping code IATA, so you are lost. Okay, let me copy, and most of the time these IRIs have a web page in which you get the basic information about this attribute. Okay, this is the definition, this is the data type, and these are the data models in which this attribute is present. Okay. Yeah, I've shown you the context and the adapters as well. Okay. It's an optional file. Okay, and it's at the root of every data model. Okay, and last, the contributors we have already commented at the notes.yaml. The notes.yaml is a file for customizing the specification, because not always it's possible that you are willing to include additional information. Let me show you with an example. Okay, the same. Oh, here we are. Okay, let's go to flight again. So I don't remember if notes is full of, yeah, there is some information. So flight entity contains a description of the generic flight, blah, 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 blah. Okay, what is this text for? Because if you go to the specification, this text will appear after the description of the properties. So this text will appear here. Okay, and of course, in other languages, it appears as well. Okay, if you are good at Japanese, you can see that there is a Japanese, this Japanese text is below here. So this is the same text in Japanese, okay, translated. Let me go back. This is the notes.yaml. This is voluntary, so if you have something additional to include into a specification, you can include it here, okay? Okay, and now I've explained every element, so I'm going to skip this slide. And these are the list of services. We have shown most of it. So the list of data models, the generator, the creator, the editor. Okay, let me show you a couple of one service, which is a bit useful. So in the main site, the smartdatamodels.org, which is the search. There is a specific menu for search. Okay, and you can search for any element included into every data model across all the data models. Imagine that you need to know, oh, do you have anything related with humidity? Okay, what you have here is all the attributes in all the data models that are capable of sorry, a couple, no. They describe something about humidity. Let me look, yes, humidity here, but it's here in this other data model. Okay, and how many are talking about humidity? I don't know, but we'll see. Oh my God, there is 21. Okay, and of course, whenever you are here, you can go directly to here to weather observe. This is relative humidity forecast. Okay, so we can go here and to find out what is talking about relative, relative humidity or relative humidity forecast. Okay, you can see the description here. So this service is really helping you out on finding anything, and of course you can filter for several criteria. Imagine we are filtering by humidity, but imagine that we need only in environment. I don't know if there is only one. Okay, we could filter, go here and get whatever we want. And of course, you can export this in Excel, CSV file, or just copy. Okay, this service is worth to be mentioned. Okay, and there are another two services. I'm stepping ahead. Yeah, which are here at the community. At the community, I've explained to you that every data model has an adopters file. So here in this, there is a database with the adopters. So imagine that we want to know how many of these adopters are IUDX, which is one of the main adopters. So you can see all these data models has been adopted by IUDX. Okay, or other, I guess, NIS is also adopting quite a few. Okay, so you can see all these data models has been adopted by NIS. There are another service which are the list of contributors. Okay, so if you are allowed to put your name into the contributors file, then you can see here, oh, there is one person. So Fernando, okay, which is providing has contributed to these data models, okay. And if you are willing, I don't know, to GR, of course, into 22 there will be many. Okay, there is 25 pages, so most of it. Let me put something. I don't remember. Let me project. I don't know. Yeah, Here there is something about the project which is called iGreenPort. Okay, and it's contributed. Oh, iGreenPort, I guess, is a former experiment belonging to I4Trust. Okay, and they have contributed with actual data models. Okay. Let me go back here to the services. So all these services, and all of them are with links. So therefore you can use them. Okay. Other services that we have. Oh, and the only service that I haven't showed to you because it's a beta version is the versions. Let me explore quickly. So for every data model can be extended, and therefore it means that can be different versions. So this is a beta version, so it's not let's say it's not running for all the versions or for all the data models. We are just debugging. But you can see that for AgriFood there is 001 version, 004, okay, or for AgriFarm there's 001, 002, and you can go directly to the version 002, okay. You can go directly to the schema. And eventually, let me take this schema, okay, could be taken into a validator. Let me show you here. A validator, here we have a link for a validator. This is an external service, but it works pretty well. Okay, so we can here. I don't remember what is this data model about. It's about AgriFarm. Let's try to find out the AgriFarm data model. Okay, if I don't know, we can go here. There is a widget. Oh, we are here. One thing that I haven't mentioned is that the JSON schema is validating only the key values. So the key values is always called example JSON. I'm going to take this. It's a version 2, so I suppose that we are going to validate. Oh, sorry, where I put the. I'm going to close some of the. No. Okay, let me find out what is the. Oh, here we are. Okay. Okay, it's validating. I've taken the example, I've taken the schema, and this schema is validating this payload. Okay. That is one of the characteristics. So we have seen this version service. Let me put. Oh my God. Oh no, I was. And now let me just review slightly what is the contribution workflow. So there are two main ways to contribute to the smart data models. First thing is that you want to create a brand new one. And another option is that you want to extend an existing one. Usually there are many people willing to create a new one and they discover that they have to extend a new one. Okay, so the first thing is that if you have a use case, if you don't have a use case, the most likely 100% no, but maybe 95 or 99 is that you are not going to get accepted. So if you don't have a use case, okay, go back, create your use case and then come back. The second question that we made, if you have a use case, if is there any data model related or any specific open regulation. This was the case, then if there is an adopted standard, we say, oh, we have to use this open standard. We are not going here for creating alternatives to open and adopted standards. Okay. Imagine that there is not such a standard, there is not any other data model related, then you can have two options. You can ask permissions to contribute into the incubator repository, or you can work in your own repository. If you work on your own repository, you have to let us know, oh, I finished, please, could you check? You have several tools for checking yourself, okay, before submitting. Let me go here to the main site. Especially relevant is here we have a direct link. Check your schema before contributing, okay? So this service, you can request in a long ARI, but you have also a form here. You put your URL and your email, and that's all. So let's click on this example. And it's telling you is replying you with 4 sections. First thing is that the schema diagnosis, let me enlarge, okay? It's telling you, oh, you have documented, oh, I've detected 23 first level properties, 0 are not described, and 0 have description that has been completed. Of course, because this is an actual example. So, and 23 are described well, so go ahead. In the case that there will be any of it which is with some issue, it will appear here directly. So instead of true, it will say, oh, this is false, missing something or whatever. The message will be here. And it is also telling you that there are some already used properties like this category, and it's telling you in what other data models is being used. And not only this, but also the description is included here, just in case that you want to copy. And of course, if there is new attributes, okay, this is not relevant, it will appear here. But in this case, there is not any new attribute because it's an actual data model published, and therefore is found. And also, it's telling you, it's reviewing if there is some metadata into the schema which is derived from, when the data models are derived from an existing regulation, if you are missing the description, if you are missing, some tags, or you are missing the license. Okay, they are not mandatory, but they are telling you a warning. Maybe you need to include something else here. Okay, I was explaining you, you can check yourself. Okay, imagine that everything goes well, then you submit, you make a pull request, and this pull request will be reviewed by us. So if you do it into the incubator repository, what will happen? So let me show you in the main site, Smart Data Models. Your pull request will appear in this section. This section here. Okay. Yeah, pull request and issues. Okay. Every 10 minutes, we are reviewing all the repositories, the 75 repositories, and checking if there is a new issue or a new pull request. Okay, so this on the data models repository, this in an aquaculture repository, this in Oslo repository, and there are something that some users is telling us or is contributing. So every 10 minutes is parsed, and therefore you can find it here. So if it's not appearing here, maybe we have a problem, and then you should contact us. Okay, we were in this workflow, and if everything goes well, we'll pass a manual review and we'll say, oh, go ahead. And this publication process takes 3 minutes. What is the other alternative? That you are extending a data model. This is even easier. So you have to do it directly on the repository where this data model is published. You create a pull request or an issue, and we check it out manually. And then if we accept it, go for the publication process, and all the specifications and all the attributes and all the databases and all the contexts are automatically updated in 2-3 minutes. Okay. And how should we document these data models? There is a contribution manual available in this link, bit.ly. Let me copy and put here into the chat. Here, one moment. But it's also into the main site. Let me close some of the, here. There is a direct link here in the upper part, contribution manual. Let me emphasize. No, I can. I want to, you see my mouse here. And it's explaining to you what are the requirements for the description. You see the same workflow. You see the files that we have already mentioned, the structure of the files, and those and the links to the same tools that we have mentioned across the presentation. So basically, the only thing, these are, let's say, the things that you can include into the description. You have to say if it's a property relationship or a geoproperty. We can separate all the elements with a dot and a space. And you can include the model, the reference model, the recommended units. If there is an enumeration, the enumeration items. If you want to include the privacy also, and if you want to describe a language property, which is multilingual, you can include here. And here you see an example. This is a fake example. So temperature, which is a property. The reference model is schema.org number. The units is degrees centigrade. The privacy is low. The enumeration is this, which makes no sense in this case, but it's for the sake of showing here. So these units that you see here, okay, are searchable as well. If you go here to search, you can go here, units, the degree, and they are telling us any attribute which has these units. Of course, they are recommended units. Okay, they are non-mandatory, but you can include it and document it here. Okay, this is the contribution manual. Let me go here. Okay, there are many other warnings and links to the tools. So basically, are the same tools that we have commented here. Okay, and also are commenting those elements which are created automatically. Okay, this is the contributors.yaml, the adopters.yaml, and all of these are generated automatically. So you don't need to review it because you are not going to interact with them as much as we know. Let me check the timing. Oh my God, I guess that we have, I'm going to finish just providing you with some inputs for doing examples by yourself. Okay. So supposedly, if you're willing to do that examples, you need these formal requirements. So basic knowledge about NGSI V2 or LD, okay? Some work with the context broker, but very minimum. And of course, some of JSON and JSON schema, Git and GitHub, and a code editor like PyCharm or whatever. It doesn't matter what you are using. So you need to have a GitHub users, okay? I recommend you to use, there is here one repository specific for you, so you can request permissions to get here, and what you do here can be anything. You can break everything down because it's for testing person, but this here, there is a schema, okay? There are examples, and possibly you have to run the test and check if everything is properly documented. And if it's properly documented, please let us know with an email or raising an issue on the main site. Let me show you. Here, there is a contact. Okay, you can raise an issue here and let us know. Oh, I'm finished. One example, please. Could you review it? Okay. And in this repository, you have many examples to play. Okay. And of course, here there is the checklist. Here in this checklist is everything that you need. Where is this checklist? So it's also available on the main site. Let me go. If you go here to the main site, you have here on the right the contribution checklist. This is everything that you need to do in order to accomplish with a successful contribution to the smart data models. Okay. I haven't mentioned the contribution agreement. This is mandatory to get finally accepted, but it's only a form with three fields, just to tell you what is your full name, what is your valid email, and a GitHub user, and if you are signing on behalf of your as an individual or as an organization. If it's an organization, then you have a form here. Okay. I don't know, for whatever reason is so space. Something is happening with the CSS. Okay, we'll fix very soon. Okay, and you can play a bit. We have already these elements that could be also useful for you if you are not willing to use those or which are into the test repository, and we'll be glad to provide you with some support for getting these data models to be ready. So summarizing, here you have all the tools for creating successful data models. If you are working for the some of the I4 Trust experiments, you have to define the classes, which are the entities. And these entities, if you put into practice, could become actual data models at the Smart Data Models program. Okay. You have here more information, which is additional. but I don't want to. So there are more information for more examples. Let me go back here if there is any question that needs to be. Let me go.
There are lots of questions for you, Alberto.
Oh my God! Oh my God! Unfortunately, I'm limited in time. I have only 5 minutes. I
If
have
there are
to.
ones you want to let me take, I'll take them. But you take the ones you think
The
most
WordPress is behind this WordPress service. Is there an API? It's not an API, but worth to be mentioned something. You can download the full database of data models here. Search, there is an additional, and here you have a link with all the data models in a single JSON file. Okay, we are already, this is very new, and this is in a very, it's not an alpha, it's possibly a beta, but you can install all the data models as a Python package here. Do it at your own risk, because it's something that we are testing right now. So possibly you get the most valuable output that you get is an error, but it will be soon, very soon, in the, let's say, in a stable format. Okay, but all the information is there. Let me address something else. Should we add one of these data model in our Orion context worker? The answer is no. No. The context worker is not meant for storing this. The smart data models, the examples, yes, but not the data models. If we need to account and trace, there is, okay. This is pointing, Roman Kravchenko is pointing to this is one sensor of CO2, okay? This is the contribution manual. For a smart AI camera, no, for AI camera, there is not, but there are some data models related with machine learning. Let me go. Here, I'm going to do the same that you can do, search. The only advantage is that I know that there is machine learning here in the data model. So here we have a subject specific for the description, not the algorithm itself, but the description of the parameters of a machine learning model. So let me show you. So there is the refML processing, the output data types, the output attributes, the source, the type of algorithm, the version, and so on. Okay. Yes, for camera, Roman has already answered specifically, and there will be more for camera. And there is, I assume, this will have to be extended to allow object tracking, possibly. It's very easy to extend. In order to extend one of any of these data models, the only thing that you need to do is to first to provide an actual example, which is the important thing, and then to create a pull request, which is as simple as create here, new pull request. And of course, if you are familiar with this, you know what you have to do, okay? And I guess that I've addressed most of the questions. Any other? Okay, I'll take yes. There is another. Is there an API? An API, yes, for the functioning in WOP. I mean that you WordPress. No, it's not properly an API. It's not the closer thing that we have is the Python package, but we are considering having an API that you can retrieve online the information of the smart data models. You can download in one shot, as I've mentioned, but this is something we have already considering. So when we say that, is that maybe in some months we'll where can I find the Python package? Okay, the Python package is here in the front end. So let me insist that it's an alpha version. So you is here. You have the in a small because it's an alpha version. So this morning was giving an error. Now we have a new version, 0.5.2, and supposedly is working. Okay, let me go visiting. Yeah, it's not in the official. It's in test by Pi. For those of you, it's called Pi Smart Data Models. Smart Data. Okay. So you have here. So supposedly with this, you are capable of installing. Okay, and I'm going to paste also the here the link. It become official soon, possibly next week. Okay, but now it's an alpha version, so be aware that this could be just not installed at all. Okay. Here. Okay, and sorry to say, but for some travel restrictions, I need to leave now. Okay, please let me know if there are other questions. Trust on my colleague Jason, which is really expert on data models as well. So I'll be glad to answer all your questions as soon as we can. Okay, Jason, then I'm giving the floor back to you.
Well, back to me. Okay, thank you very much, Alberto. Go and catch your flight.
Okay, hopefully. Okay, see you.
Right.
Bye-bye. Sorry to have leaving.
Right. Right, back to me. Before we do anything else, I've not got a flight to run for. But what I can do is I can place my LinkedIn details into the chat so that if you've got a question and we get past the 6 o'clock, which is quite likely to be honest, and you need to run or what have you, you can always contact me directly, and I can answer stuff as necessary. Now, what we've done so far, and actually I will move this across. Hopefully, you should understand that in order to do any data sharing exercises, the first thing you need to do is to define your world. You need to work out what's going on, what's happening. Now, I am now going to start showing you some proper examples using a proper context broker. The slide deck doesn't really matter. What I'll be doing is I'll be showing stuff on screen, throwing in Postman stuff, but we'll just briefly go over what we've had beforehand. I get my right. Oops, where are we? Yeah, there we go. Get through my slides. Once again, we've got the useful JSON link. One of the things which came up with naming is that you've got this ability to change the names of attributes. This is called a compaction expansion operation in JSON LD. There's a useful video on there which wasn't in the previous links. As I've stated, this is just a structure. This is obviously this review from the previous one. This is separate slide deck, as you can see. Now, you have started to see what the core context is. The core context defines all these various elements, but the important thing I want to point out here is actually on the right-hand side at the bottom, right? The right-hand side at the bottom has got an @vocab statement, which is stating that if you do not define an element, it should fall into this so-called default context. This means that if you make a NGSI LD request and you haven't provided names, we'll provide names for you. Problem is, of course, that those names are not shareable. Hopefully, you have realized that the idea behind all this smart data models stuff is that we have names in well-defined IRIs in common so that we can pass things from A to B. So this is there to catch you if necessary so that your requests are valid. However, you need to start off by defining your world. Now, see if I can get this to work. I'm going to go through this. So I'll drag that across. Is it coming across? Can you see my screen? I think you can now, right? Just a minute, it's that one. Just a minute. Okay. So, yep, fine. You can see the screen. Okay. So, this is my world. this is the world I have defined for my little my little demo. I have a small farm. I've got a farm which has got various attributes: opening hours, who owns the farm, what the address of the farm is. I've got various types of farm building, like barns and conservatories and cow sheds and what have you. And I've got several devices. Now, they've got various different elements here. These are all taken from the smart data models examples. There's a set of tutorials, NGSI LD tutorials README, which will give you information about what my world is. This first thing about working with understanding AtContext is basically what we've been trying to drill into you for the last 2 hours. You need to have an understanding of the world. I have also described which fields I need for which of my various different types of element, like what is a filling sensor. I'm using SARF here as my my sensor type. I've got range of values saying what the values of the various attributes are. It should be starting to make sense to you, because if I am in a situation where I need to pass data over to someone else, I need to have it in a machine readable format. I need to have it in a human readable format. This is a human readable format saying this is what I expect for these attribute names. And what I have here, there's a little tool which I won't demonstrate, but it's a like an early version of some of the stuff which Alberto was showing to help generate these things. There's more details in the actual tutorial, but we haven't quite got time for it. What we actually need is an NGSI LD, a JSON LD AtContext, which consists of it's a JSON file, obviously, an AtContext attribute, and then a series of mappings. So if I want to have a mapping to, say, where's my mouse gone? There we go. If I want a mapping to, say, animal, because I've got animals on my farm, I'm going to call it a FIWARE data model animal. If I want to do it to various people, you've got male and female defined there, you've got cowshed defined there. You can see that for every single one of the elements I had in my Swagger file has been pushed into that file, generating as key value pairs. That's how we're starting off this world. Now, oops. Those of you who are familiar with NGSI V2 know that it's got JSON payloads. NGSI LD has got both JSON payloads and JSON LD payloads. It's slightly different endpoint. And I said, with 2 other things we need to cover over the next 50 minutes is also registrations and subscriptions. So let's actually just get onto a little demo. We might as well start using the thing. What I have. There, isn't it? This one here. So what I have here, I move up to NGSI LD, is I have a series of tutorials. I've got a little Docker file. This is just the getting started. Obviously, you wouldn't necessarily want to be using Docker for a large production system, but what I've got here is I have an Orion context broker, which is a Dockerized version of it. I'm starting it up with the debug and formatting and what have you. And I have a tutorial in the background, so I can actually go off and do stuff with it. Where are we? That one here. So I've already got it started. You can see I've got absolutely nothing in there, but importantly, I have this AtContext file available so that it's publicly available on the internet, so I can actually start doing things with it. I'm sure you're familiar with Postman. It's basically just sending off stuff in there. Basically, it's curl statements HTTP. I can obtain a copy of my AtContext file, which is defining all those elements like tractors and barns and things like that. I've got several versions of this file. I've got an alternative AtContext, which I think is called alternative, I remember right. Is that right? Yes. No, it isn't called alternative. What is it called? Just a second. Alternate, not alternative. And you can see, if you look in this particular file, I've now got the same definition of the world, but all my short names are now in German, so that I can potentially use a different setup. And what's happening to me at the moment is that my mouse keeps freezing. So hopefully this won't keep on happening. Okay, so I've got a little Orion context broker running on port 1026. You can do a quick heartbeat check to see what the version is. You can see I've been up for 35 minutes because I was doing stuff whilst Alberto was still talking, and you can see what the release date of that particular version of it. I think this is Orion LD 1.1. 1.2 should be coming out by the end of the year with additional bits and pieces. In order to create an entity, what I need to do is, you can see at the moment I'm not doing anything particularly clever with my attributes, apart from the fact that I actually got it as LD plus JSON. What I have here is, these are my attributes. This is my first building in my world. What have I got? I have got elements like category, which is a property, or address, which is also a property. I'm just doing properties to begin with. I can move on to other things later on. And at the bottom, I think we'll find this one if I can scroll it. Yeah. I am having great difficulty moving my. There we go. At the bottom, I've got this reference to that AtContext file. So actually, this what it's saying is that map all these names to those long IRIs, which we've seen elsewhere. You can see here is a geo property. It's in GeoJSON format, so that's going to be a longitude of 13 degrees east, 52 degrees north. In other words, it's based in Berlin, and it's got various attributes. So I wish this machine wouldn't keep freezing on me. There we go. So I send that, and as you would expect, this is an HTTP. This is a REST API. What I've got is an HTTP response code saying 201. It's created. You'd expect that. If I try and create it the same element the second time, as you would expect, you get an error message. You can't do that. We can't create things twice. Obviously, this is a REST API, so post is create, and we can modify things as necessary, and it gives you back a human readable error. I can create a second entity at this point, and you can see this is got a different IRI now. But what I've done here is I've instead of putting the AtContext into the payload, I put it into a header using the link file for header format, which is, again, it's a HTTP specification. Create it. I've got something in there. I can now start looking for stuff. Now, if I don't put in a link header, and I don't, when I'm doing a get, I need to put in the link header, and I'm asking for an IRI of type building, you will see that it does get something back. And you'll notice that my address is now saying it's actually a schema.org address, which is really rather useful. Now, that means that someone can use this expanded IRI and pull it back to whatever they are into. If I look at various other elements, you'll notice that some, but not all of them, are expanded. The reason why not all of them are expanded is one of two reasons. If you have values like location, as I pointed out, location is actually to be found in the core context. That is always going to be returned as a short name, because by definition, a GET request will always supply that core context. And indeed, you can see that I've not supplied a context, therefore it's saying I'm using core context. However, there are also other elements, I think, verified. If I can, my mouse is not playing up at the moment. There we go. elements like verified. Verified, I deliberately haven't put anything into my AtContext file, and notice it's using the short name. This is using this a default context. So you can see that I've got information now. I don't have to get information. I can get NGSI V1 entities, and I can filter by type. I need to supply a type. I can also get back a well-known IRI. Obviously, this is Postman. You can see you can do it using curl if necessary. And if I just get back that entry by ID, once again we've got all the information you would expect. Just a minute. There we go. It is possible, or I could. It is possible to reduce the amount of information I have got. That should be LD plus Jason here. So if you add in, again, type is building, but I've got a context. So the building is that IRI building, and I add in options key values. What is returned is just the values. If you notice, I've lost that verified element. It's just giving me the value back. Now, depending on your use case, you might just want to return what the values of the elements, or you might need metadata. If you need metadata, you have two options here. You can either use normalized, or you can use concise, which we'll go into more details tomorrow. But the normalized is the default. If I just remove options key values for a second and send, you can see I've now got type and value. This is type and value is really, really useful for machines. You need a normalized version for machines. It's really a little bit annoying for humans. So, oops, Control Z. Oops. Now, oops, where were we? Just a minute, I'll close that one. I'll go to that one. If we change the header type, if I go for application JSON, the @context is removed from the response, but you will see that the @context is still there. It's just in the link header rather than in the body. Obviously, reduces the size of the body. If I go for application geo plus JSON, and I'll make this normalized again. Look at options key values. That right? Body. Oh, it should be a question mark. That's why. My bad. You'll see that what you're actually getting returned here is now in GeoJSON format. As I mentioned earlier, the locations, places, observed areas, what have you, are in NGSI LD are down in GeoJSON, and you can actually return the whole entity in GeoJSON if you want to display this on a GIS system. So far we're doing gets. Gets are relatively simple, and of course you could have millions of data attributes. So, and you don't want to get hold of everything all the time. So you can apply various different filters. So if I wanted to just get types of building with the name, which you've got the name Big Red Barn, I'll just show you the. I can send that. I would just get back the one building rather than all. And the Q parameter is the way that a context broker can apply queries. And what it happens is that it passes information to the context broker and any other registered sources to saying, do you have any buildings with Big Red Barn? And as you can see, because I'm doing it normalized in this one, You can see the name is big red bar. There's the usual things you'd expect, greater than, less than, equal to, not equal to, and what have you. Going on to my alternate context, those of you who speak German will notice that now I've got type Gebäude rather than type building. Obviously, Gebäude is a short name. It's local to my system, but because of my alternate context I'm using here, that maps again onto my long IRIs, so that this type is a well-known type. And again, I'm looking for name, big red barn. You can see when that comes back, it comes back with address in German, and it comes back with category in German, and so on and so forth. What you will notice, I haven't changed the names of the sub attributes in the address, because what has happened is that I have defined the elements, or the element address, or Adresse in German, as being a schema.org address. And the schema.org address assumes that you have postal code, address locality, address regions, street name. So those would not be changed. You could, of course, overwrite these things if necessary, but then it's not actually giving me what I would expect. What more? Well, you can actually use the Q parameter in multiple ways, with the syntax shown here, which has got each element in quotation marks with comma separated. You can then say, okay, give me things which are either a barn or a farm auxiliary building, and once again that will nicely come through and filter it. There's two more filters you can do. You can do a filter on a sub attribute of a value. So address has got a locality. You would need to use square brackets for that, and you can see in the URL up here that the square brackets do need to be IRI encoded within Postman. If you're talking machine to machine, it's almost certainly going to do that anyway, but this is just showing all the guts of it so that I can get the value coming through. I can also look for a property of a property. So in this particular case, I'm looking for the address which has got metadata saying it is truly verified. That's using dot syntax. All of this information is fully available on the NGSI LD tutorials. So if you want to review the syntax, it's all going to be there. But I'm trying to keep moving because we are relatively short of time. The final thing which you can do on basic get is that you can run geoqueries. So because I have defined my entity with a location, and because location is defined in the core context and is defined as default, I can run a query saying, can I find buildings within a certain polygon? Can I find buildings near to a certain point? Again, the full syntax is described elsewhere, but you can see once again we need to have that square brackets around the longitude, latitude. It's long lat rather than lat long because that's the way that GeoJSON describes things. The maximum, this is looking for elements near with a maximum distance of 800. 800 is in meters by default. So again, once again, I can see which ones are near to the Brandenburg Gate, and it says here, okay, my barn on the Strasse des 17 Juni is nearby, but the other element isn't. Now, there are multiple context brokers. There's the Orion LD context broker. Where's it gone? I've closed everything up by mistake. There are also other context brokers such as Scorpio and Stelio. They all use the same interface. So if we are trying to look at the same thing, we could actually run the same request using Scorpio. Scorpio, in my case, is just looking at a different local host. You can see, okay, so if we want to get by ID, for example, it would just be localhost 1990, whatever. It would be running there. So you want free to use whichever context broker is following the ETSI specification according to the way you are wanting to do it. Right, I now need to swap over to another tutorial. So what I'll do is I'll move to the / for subscriptions. I'll go into relationships. Doing everything and restarting it again. So in summary, you can see multiple ways you can do for creating an entity. I've shown you that slide, those slides previously, and it says what location, fine. Okay, now moving on to relationships. Relationships are fundamental to machine readable linked data. The idea is that you can traverse from node to node if you know what you're talking about, and therefore each element defines a link within the data model. Relationships, as you would expect, are type relationship, or if you are not supplying some sort of context, and you always are, but technically it's an @context, which is defined, an @type, which is defined as type, and it's that URI, which is actually defined as relationship. No one would actually bother putting that stuff in, but I'm just being and you can see in this particular case, you could either have a direct relationship, or you can have a relationship of a relationship, or however you want to follow the system. So for the entity relationships, I can start off by creating several temperature sensors. In addition to the simple post, patch, put, get interface, there is also a batch endpoint. The batch here is entity operations / upsearch. So if I insert that, you can see it's giving me data, and if I insert it again, it doesn't complain. This is probably the commonest endpoint for inserting data. You can see I've got information here about my temperature gauges, but you can also see I've actually started doing things like adding in metadata. Going back to Alberto's point about saying, my temperature is in Celsius. Well, my temperature gauge value is 20, and it's again, it's using a UNCFACT unit code to make sure that you understand what that 20 actually is. I can also do this, create multiple filling stations. Here you've got unit code C62, which is a 0 to 1 definition. You can see it's created some entities there. I can retrieve my devices as you would expect. And at the moment, there's no relationships added in there. But obviously, I can add a single relationship quite easily, saying, my temperature sensor is reading the temperature from building 1, which we created earlier. And if I send, my temperature sensor 2 is found in the barn, and temperature sensor, filling sensor is found elsewhere. And there we go. Here we go. Once again, this is an update. And from there, you can obviously see, so let's find out temperature sensor 1. What do we get back? We get back the controlling asset. If I remove, you notice it looks like it's just key values because it's options key values. If I go back to the parameters and remove options, you will see that actually it's a bit different. The full data has got a type of object rather than a type of value, because this is a relationship, and this, as you can see, is an IRI, which of course, if I put into my entities rather than temperature sensor 1, I did building one, I get the data from that. You can obviously make queries to work out which building is the temperature sensor within. This is an example where I'm using options key values, and I'm just getting the the attribute controlling asset. If you're wondering why it's called controlling asset, it's because the standard SAREF device model calls it controlling asset, and the smart data model device follows the SAREF terms. As I said, we don't make these up ourselves. We're using the naming conventions which exist from pre-existing systems. So once again, I can just this is set. You can see the options here. I'm just getting the values. I don't need the metadata. And once again, I'm saying I just want to get who the controlling asset is. Unsurprisingly, it's giving me less and less data, but it's more and more concentrated to what I'm interested in. You can do it the other way round if you wish, by slightly changing query. So the Q parameter, give me the controlling asset which has got the value, and give me the entities, and it's saying, okay, same thing. It's saying temperature sensor 1 is in building farm 1, and filling sensor 1 is in also there. This is again where you want to be using a common naming convention, because obviously it helps with your queries. At the moment, I've only got 3 elements which are within one context broker, but you've got to remember that this is designed for large scale systems. So these could be in a completely separate context broker. I would need to be making a query across other systems. If you want to create a bridge table, once again, you can do that. You can have, let's say, an entity like a task, and a task is assigned to a person or to do something in a certain field. I scroll that down again. You can see in this case, what I'm doing is I'm doing a spraying operation, and it's scheduled to happen last summer, I think it was. So you could then say get the information for that, and you can read this information quite easily by putting in an appropriate thing. So an appropriate request. So if I look at the curl request for this one, you could say, okay, this bit at the top. Sorry, I'll work from the bottom. This is saying I want to get back JSON as opposed to LD plus JSON or GeoJSON. This is saying I want to use the following context. Again, this is something which, once you've created your world, you personally, when accessing your own context broker, will always be using that link header. Now, if some other company, entity, what have you, wants to start using that data, they can use your link data, or they can request using their values. So again, these two tend to be fairly static, and this is the bit which is where we are making our query. I'm saying I want to find out tasks, type task, which is using the herbicide 001, and if I send that, you can see that it returns back the field attribute, because that's what I've got. So this shouldn't be that difficult. This is just how relationships work. Now, if you want to get into more detail, you could define the fact that within the adjacent context, you can have an ID and type saying this is an IRI which is holding this value. However, that is only if you're talking about key values. But what you could also add in, and this is something I alluded to earlier on, is that you could have an @graph element added into your @context. Remember, my @context at the moment, I'm keeping it simple. It's just the key value pairs. You could actually annotate information about this. So, for example, in this particular example, I'm saying, okay, I have entities of type product, and product is an RDF class, an RDF being defined as one of my incoming values. And I was saying that I have comments about this particular thing, and they comments are in certain languages like Japanese and so on and so forth. Now, at the bottom of that, you can see that there's a definition of a machine readable link. We're saying, okay, when I have the attribute requested by, it can be found on shelves and stock orders, but it is always going to be a person. Now you can see that the definition of these various elements are defined, in this case by schema.org, so that the machine can understand what's going on here. Is this necessary? It's necessary only, it's not mandatory. It's necessary only as you wish to expand your data space to a wider and wider audience. If you can get your participants to agree just to use the attributes, and you all know what you're talking about, you say, okay, we all have weather using the smart data models weather model. then that's fine. You can do that by agreement. However, in the broader sense, the JSON LD sense, the more data you can stuff into your AtContext, the more likely it is of use to someone else. An example is if you have an attribute which is nearly the same as, I can't remember what the ontology version of that is, but you could then get data from multiple sources, and their big data analysis, for example, could say, well, I can't use attribute X because they haven't got it, but they've got attribute Y, and that's sort of the same. So this is, as I say, this is made, the @graph element is to allow machines to talk what you're dealing with. I've just done the demo beforehand. I'll quickly move on to subscriptions. This is going back to those 5 or 6 point bullet points which I mentioned at the top of the hour. As you notice, I've only got about 25 minutes left, so I'm going to keep moving quickly. As I said, all these tutorials are available with more information and subscriptions. And you can see once again, I'm waiting for my @context to be available, and it should be available now. You're going to tell me it's available? It's getting there. Yeah, that's interesting. It's failing on me. That's not Sarstream, it's Kitematic. I might need to restart. Here we go. It took a bit of time to finish it up, but it's bring some data. We've got a few more elements placed into this system, and have I got that working? Okay, well, I've got 2 context brokers working for some reason, so I hope I've got the right data in there. Let's see if I can get this working. That's right. So for subscriptions, a subscription is purely going to say if the entities either defined by type or by ID or by regex, and looking at a specific attribute or set of attributes. So it's saying if the filling attribute of the filling level sensor has changed, and then you can add in your Q. So your query parameters, you can see this is really quite complex, this query parameters saying if the filling level is greater than 0.6, use semicolon for and the filling level is less than 0.8, and the control linked asset is farm 1, then it will do a notification. The notification is in various formats. You can have key values, which is a simple form, or you can have normalized, or indeed there's a concise, which I will deal with tomorrow. At the moment, assume that you've got a machine which is reading this, send it to send the expected data to a well-known endpoint. This is low stock farm 1. So it's saying, you know, I've reduced my my filling sensor to a certain level. It's going to cause problems. If I send that, invalid queue filter, because you'll need to put quotes, if I remember rightly. You can see that there's errors, and I know why that is. Just a minute. The point here is I need to put %22 around the IRI, but what I'm going to do is just delete it because I don't need it right now. That when you've got a relationship like that and you're talking about a string, you need to put the %22 encoding in my request. I'll just have to update the tutorial at some point. I can do the same thing in a different format. I'll just get rid of this bit as well because I don't need it. Now I can see this is actually the same thing, but I'm doing it on a different range. But what I can do as an example of is that in this time I'm going to get in normalized format rather than key values format. So once again, it's giving me those two values. And there is a well-defined format for this. So if I just go back on tab, there we go. That's what I want. There we go. No, not that one. That one. Thank you very much for everyone who's been attempting to contact me. I will get back to you in a second. Localhost 3. Two of those on there. You can see I've got a little application running just to show what's going on. And one of the things I've got is the app monitor is saying what subscriptions I have recently received. I've received nothing. At this point, I should be able to go to my devices. If I start removing hay from the farm, you can see it's going down and it still hasn't hit 0.8. So at the moment, the event monitor has got nothing in it. If I now remove some more hay, I need to remove some more. There we go. Is it over there? No, it's just on the borderline, so I need to put another one. There we go. And you can see at some point it has started sending me payloads. Now the payloads in NGSI LD are again well defined, but you can see I requested controlled asset and filling in key values format, and that's what I've got. It also says when it sent me the data, and it says what the data is. These are the entities which have changed. If I keep removing more hay from the system, I'm going to go below 0.6. .056 should be okay. And look at the event monitor now. You can see that this now you can see that I'm receiving a bit more data because I'm getting this in normalized format. Why would you want key values? Why would you want normalized? Well, it depends what you're trying to do with the data. There are systems where, let's say, you want to, you could use a subscription to upload data into a second context broker. There's a component in the a FIWARE catalog called FIWARE Apollo, which would do that. In which case, you'd want all of the data. You'd want this normalized format to see what's going on. In other cases, you might just want the key values because let's say it's an alert. You just you want to send this to a microservice to say send an SMS message to the farmer to say you're running out of hay. In which case you don't really care about all this additional information. You might as well keep the payloads nice and small. You can see the last element I received was this second one, which has also got a different IRI. So, and again, it would be possible to return the whole entity or parts of the entity. This is, as you can tell, used for asynchronous systems. So you can see here, I'm doing this in a shelf, various parts of the payload. You are also various gotchas around here. Firstly, assuming you're using a Dockerized system, you need to make sure that the IRI for the endpoint is accessible within your system. You don't want to put localhost in there because that would be, oops, gone too far. It will be localhost for the internal to the system itself. This is why it's calling it tutorial, because that's what the name of the that little viewer is within my Docker network. Second thing, obviously, you need to make sure that you are watching an attribute that is changing. If you're not, if you don't specify watched attributes, it will go on all attributes. But obviously, if you misspell the name of the watched attribute or something like that, it just won't fire. Again, Q is optional. Obviously, you want to make Q as specified as possible. This, as I said, should be in percent encoded quotes if I'm trying to put a string in there now. This is to do with the version of the context broker I'm actually currently running. It's got stricter in the later specification. And one thing which I haven't got in here, but I could have put it in, is it is possible to throttle your requests. So if you have a rapidly changing attribute, you may only want to inform a sample of the system by just saying, okay, only update this every 5 seconds. On the right, you can see that's the key values payload. This should start looking quite familiar in that you've got an ID and a type, which are special, and then you've got whatever the definition of your model is. I've got located in number of items, low stock, etc., etc. That's the sort of thing which you can deal with. So that was subscriptions. Registrations is going to get a lot trickier. This is has been well defined in the NGSI LD 161 specification, which came out in September. And the way that registrations work is now dependent on what sort of registration you want. The default registration is a federative registration, which means give me what I've got plus what they've got. Okay, so a federative registration is usually a get. So if I have got attributes like I don't know, address and number of floors in the building, and another NGSI compliant interface or another context broker has got information about what tweets they're sending, let's say, then I can say, okay, get this information from this endpoint. Once again, the endpoint is changed based on your the Docker network if you're in it. There used to be an attribute called properties. It is now two separate ones. One's called property names and relationship names with the updated context. and you can use that to retrieve information from elsewhere. So I've done that bit. I need to get onto the other demo to get this one sorted out. There's a reason why the NGSI LD tutorials currently doesn't cover registrations under NGSI LD, and that is, as I said, because this is in the process of being updated at the moment. So I'm just going to show you the NGSI V2. Oops, wrong one. Oh, probably gone back one. That's why. There. Oh. Yes. You will see that there is there are a series of tutorials for NGSI V2 out there, and they are also include a couple which are NGSI V2, NGSI LD for V2 users. Oh, in LD, that's why. That's what I meant. You can see there are more tutorials on NGSI V2 within LD because obviously it's the older format. We've had more time to get these running. There's one called LD subscriptions registrations. Switch over to the V2 LD registrations. Now, if I'm creating a registration, this one is using the newer property names attribute. I'm saying I've got a building and I've got some sort of information coming from elsewhere. I have got the ability to pass in a JSON context should I need to. And that is saying that, okay, this particular source doesn't understand JSON LD, always do the conversion to the JSON LD context to make sure using this context so that you pass into the request a query with their preferred short names. There are, as I said, various different modes. The default mode is federation. Get from me, get from that broker, add them up, merge them all together. I'll show some more details later on. The exclusive mode is saying my context broker does not have this attribute and never can, but my broker over there will be able to get hold of that information. And operations is again a mask. The default operations is gets and subscriptions you can run, which is used for federative brokers. But there are a list of operations you can get just to update stuff. So I want to change things, or in this case, retrieve stuff from this endpoint. If I was to make a request on that endpoint directly, I would be able to, through the NGSI endpoint, I'll be able to get hold of additional information. So I can create, again, post this time, instead of NGSI V1 entities, it's NGSI V1 source registrations, like the subscriptions one was on NGSI V1 subscriptions. I send that, and this is okay. So what I've done, I know what I've done here. Okay, so I'm just going to have to remove a few bits and pieces because I'm using an older version of the context broker. So what do I need to get rid of? It doesn't like property names, so it likes properties. the process of updating that. Is that going to fail? It probably is going to fail because it's probably not going to like the mode exclusive either. So just a minute. Yeah, oh, it's all right. That's fine. Now, at this point, if I check the registration, it will tell me these are the registrations I've got in progress. And if I read from store 1, you can see I've got my building there. Oh, it's got dataset ID as well. But you can see it, all of a sudden, as well as the basic data I've got in there for the address and what have you, I've got some tweet information which is coming from my external source. For some reason, the mouse keeps sticking on me. I think it's running out of resources. And you can see that in this case, I've got some Douglas Adams quotes. I could, of course, instead of going for my context broker here, I could go and just redirect from the context source, saying this is actually the forwarded query, which is saying, for that path, which was the one we put in the registration, plus standard stuff for context broker, NGSI LD V1 entities. And then it's saying, well, I had just registered the attribute tweets, so I'm just going to filter at the attribute tweets, and it says I will give you back the information. And if I wish it wouldn't keep doing that. If I send that, you can see going for this context provider, I am actually getting some proper values. I could, of course, update that to a different quote. Now, this is more typical of the federative case as well, that I have multiple brokers associated with my system, and somewhat thing has happened over there, which obviously I don't necessarily know about until I make my read. When I get my read, you will see that this time, once again, I've now got the new context. This is the updated information. If you're taking, say, weather information, it's the latest version of the weather, as you'd expect. But it is also possible, assuming you have the appropriate rights, to be able to send from broker 1 saying update the value. Now, obviously, depending on how you've set up your registration, whether it is capable of doing a patch operation, whether the receiving endpoint will let you do that or not, whether you've got the appropriate security elements in place, this will cause the update to occur out there in the world. And of course, this information, because I've got, in this particular case, I've got an exclusive registration, it means that the context broker, Orion, hasn't got this information. It's the registrant that has got the information. And the registrant, when you run it, will then update the information to get more quotations, which are always at the bottom, annoyingly. There we go. So I never could get the hang of Thursdays, which is the correct day of the week as well. So that very, very briefly covers the subscriptions and registrations, which goes in circles as to where I started, as to what does a context broker do. So one final slide before I close is, what's the point of all this? Right. The whole point about this, the whole point about using all this AtContext nonsense and putting it into your system is that you allow third parties to understand what's going on. So if you ever go to a search engine and it returns back products, right, and it gives you a star rating, how does Google know there's a star rating there? It's not because they know what a star rating is. It's because some proprietor has put in some JSON LD into their web page, which then Google can read and interpret. It knows that this web page has got a schema.org product in it. A schema.org product is expected to have a star rating. The star rating is expected to run from 1 to 5. So you can see that you can get hold of this entity and it can get back hold of information at 5-star rating. Going back to look at my tutorial, is that you could imagine a system. This is getting on towards data sharing. If I've got a shelf which needs filling, I could pass the information as linked data to another third party, in this case an ARV, which would then be able to understand what is meant by shelf, what is meant by filling level, what is meant by product. So you can actually get hold of the information directly. You wouldn't need to reprogram your robot each time you've got a new customer. So the initial hour and a half covering define your world starts paying benefits once you've got a real product. So we're coming up to the 6 o'clock. I am still going to be online to answer questions, but that is the end of the main bit of the presentation. So if I just stop sharing, you can see me there. Hi there. Any questions, folks? I'm going to move this across so that I'm not staring on my right all the time. So yeah, I'm currently sitting in Berlin. Do we have any questions? I'm going to try and work out what package Python. Will I share the Python Compose doc compose is? Yes, I can just put that directly into the chat. Just escape that and get rid of this. All of the information is, where are we? Right. All of the NGSI LD tutorials can be found on GitHub under the Fireware account. And we also have readable documentation, which is, again, this link here. We also have this readable documentation, which is the LD. There's also an NGSI V2 version, but the training for this course is going through NGSI LD in the main. So just look in the Fireware GitHub. We've got the documentation there. So going back. Okay. So I did show an AWS. There will be more sessions later on in this course about doing proper deployments. One of the things about the tutorial deployments is that they are deliberately very, very, very simple. So they are wrong for production scale. It's just trying to. The idea is to try and give you a system where you can actually start dealing with your APIs rather than something else. So if we want to connect our smart campus to Fireware, we host our own environment, refine our own world there, and that's about right. Whatever your system, you have got data somewhere, right? Now, you decide which subset of that data you wish to pass into a context broker. If you've got devices, there are a series of so-called IoT agents. That's day 3, I think it is, which would then be able to do that upsert, which I showed earlier on in the system, and that would put the data into the context broker. If you've already got a running proprietary system, you need to work out what subset of data you want to put into your data space. You won't necessarily want to put everything you've got into the data space. It will be the elements as necessary. That data then can be considered as your digital twin. Other people can then query it, assuming they have appropriate access rights, which goes back to what was said right at the top of this morning, was saying that you need to have some form of trust relationship between the stuff. Yes, that was the entity relationship one for the LD. In general, we've got a lot of tutorials, and they're constantly being updated because obviously the NGSI LD specification itself is being modified and worked on. So the stuff I was showing you about mode, for example, needs to be added into these systems. How can we get a creation so that we get a notification every time a new entity is created or an existing entity updated? That's tricky. For the updated, it's easy enough. Because you can just do a query and you don't restrict the watched attributes, and you don't add in a queue. It will just say there's something there. Entity created, there are various additions which are being added in as to which subscriptions you can do. At the moment, I don't think you can necessarily specifically do one on creation, but obviously once it exists, you can it's going to be the creation counts as an update, so that would also be the original thing. I will have to, in order to give you the most appropriate information, I would have to get back to you to point out what the syntax for that is, because that is currently being update, or is it either updated in NGSI LD 1.6 or will be updated in 1.7. So I need to check what the current syntax is. So I think we're done for today, unless there are further questions. Obviously, I'm open for further questions. I will be running various courses. Oh, there's another question coming in there. Various courses in the next 5 days. So if you suddenly remember something in half an hour, don't worry, we're still there. So in order to implement real-time data fetching from a device, the device is to push to a context broker. Yes. Because there is again a proposal to get streaming data into the system, not currently in 1.6.1, possibly 1.7.1, but yes, typically a device would be pushing data into the system. What about historic data? That comes in the next session. There is a temporal interface which I will deal with later on. You can use a subscription or context broker to push that to a database, if that's your preference. If you're looking to do a federation of a temporal interface, you're going to have to use the NGSI LD temporal interface. I can give you a better answer than that. Wait a second. Lost it. Right, okay. Over the last 4 years, there have been a series of webinars been running covering all of these things. That's the full list. And specifically to answer your question, which was, that would be the timing. How's it gone? Trying to find the right one. That's the right one. Right, that's me again. Right, okay. Actually, I can do more than that. Show more. Right. Didn't I get the link? That's what I wanted. Right. So for a brief summary on the temporal interface, as I said, we'll be doing more on the temporal interface later on. That is the relevant section of the video for the difference between time series and temporal information. Will I be covering visualization tools, training and Grafana later on? Probably not sufficiently for you to be happy. So again, I will pass you to, yes, we will be doing some, but there is a, gone. I've lost it. There is a, where's it gone? It's fairly recent. There is again a video, about an hour-long video, which will cover that in more detail. Which I'm trying to find out where I've left it. That's the one. So specifically, if you're interested in how to connect FIWARE and Grafana, that's the video you're after. There are actually, I can put that up as well. Academy. There is a listing of all the various FIWARE courses in the FIWARE Academy. There is, I'm trying, actually, I might be able to show it. That is a static listing, but that one, I think. Okay, wait a minute. Right, damn. Right, so in addition to the link I just posted, there is actually a way of filtering all the recordings we've got, which means if you're in, we've got so many people online, I don't know what you're into, right? If you want to filter for FIWARE and AI, you can filter with FIWARE and AI on that. If you're interested in Grafana, you can put Grafana into the search box. It'll find something in there. The reason this is not an official part of our website yet, so this is a tool in progress, but it's easier than just searching on the net. As I said, we've got over 50 videos, everything from stuff which your CEO would be interested in to how to actuate a robot using FIWARE. There's probably something which is in more detail than we can manage through a 15-hour course. Some of this information obviously is out of date because it's been happening over the last 4 years, which is why we do the basics over and over again and re-record the basics. But that should hopefully get you started. If it doesn't, again, ping me on LinkedIn and I'll point you to the right direction. Now, someone was asking stuff about something else. Something about AWS. I'm trying to, for some reason, that's it. So hopefully we've covered historic data. About AWS, I don't know is my simple answer. I would have to, if this is to do with the Eiffel Trust training, you're going to have to ask a question directly because that will be to do with implementations. I know, for example, the AWS Smart Territories application pushes data into their IoT stack and then offers an NGSI LD context broker. So it's a Scorpio broker on Orion, which is the one I showed. So you could use that data source as one of your entries into your data if necessary. I assume that question is probably better pointed to someone else who isn't me, but I'll see if I can find out any further information. So, it's for experiment. Okay, so that must be a question you want to ask directly to the people in charge of the I4 Trust. So, does that kind of answer your question, Kirillko? The other thing is that you can ask your mentors these questions directly, because I haven't a clue. And they probably haven't got a clue either, but they'll be able to ask that question further on. So, any more questions coming down here? Yeah, dashboards as part of your deliverables. Again, presumably you're part of the I4 Trust stuff. If you're doing the I4 Trust stuff, then the first stage involves filling out your IMP, which says what you're going to deliver. If what you're saying, your IMP says we are going to deliver a dashboard, expect that when the final minimal viable product is actually assessed at the end of the project, before we hand over the money, that yes, we will check that there is a dashboard in there. If, however, you say there will be no dashboard with this application, then obviously you'll get away without having a dashboard. So, any further questions? I got a thumbs up. That's kind of you. I have one more. Oh, go ahead, Marcus. One thing to realise about context brokers is that there are two modes. No, yeah, two or three modes, right? For Orion, specifically Orion, the Orion default mode does not hold temporal data at all. Context brokers have no memory, right? The temporal interface, which is going to be mentioned later on this week, is an optional interface. And by default from Orion, it's not there. So you will always have just the current data. So when you say store all of the data, the answer is, in that case, no. If you are using, say, a Scorpio broker, or you're using Orion with the temporal interface enabled, then you would get the full temporal information of the building. Buildings tend not to change very much. So obviously, they wouldn't expect to have that much data in there. But yes, you would get that data, and you'd get the storage burden of trying to keep the information for everything. Again, looking at the video link I put in earlier, there is a kind of intermediate way of doing it. Well, yes, you're quite right. There's a kind of intermediate way of doing it, which is there is an element in the Fireware catalog called Quantum Leap, which listens to a subscription. You all understand what a subscription does now, and that pushes data into a time series database. Now, the advantage of doing that is that you can select certain attributes or filters such that you would get the data going into a I think it's timescale. It's timescale or Postgres which are available. I think both options are available. And then the advantage of that is that obviously you can just get a subset of attributes. So if there's stuff you're not interested in, or not interested in tracking, or not interested in storing, then you can just ignore that area. The downside of using something like Quantum Leap is if you're trying to do a federation of context brokers and requesting temporal data across a federation. That obviously won't work because the subscription is limited to the one context broker. So the final point there is that it will depend on your use case. Yeah. So yes. Yes is the simple answer. For a context broker, there must be a backing database which holds the latest database. Now, the latest data value. It happens that for the Orion LD instance I was showing you, their current backing database is MongoDB. The drivers for doing the push are in the process of being updated, so that could actually be swapped out to, say, DynamoDB in relatively near future. If you're using Scorpio, their current backing database is Postgres. If you're using Stelio, it's currently Neo4j. There is a backing database, it's not necessarily MongoDB. If you are trying to do the time series, or you've got time series switched on, you need a database which is capable of doing that. Within Scorpio, I believe that's Postgres. I'd have to check. I can't remember what their Stelio does at the moment. With Orion, there's a separate, I think it's Postgres. Timescale, a separate timescale database which is used for that. CrateDB is one of the options which is available for Quantum Leap. So, Giuliano, you were correct, but I've given you more details. Okay, well, like most comedians, I can say I'll be back tomorrow. I'm here all week. My name's Jason Fox. It's been a pleasure dealing with you this evening, or this morning if you're over in South America, of course. I'll see you soon.